Hi everyone, welcome back to the channel. In this video, we'll be discussing the Leetcode daily challenge, which is search insert position for 26th November. So the problem says that you have been given a sorted array of distinct integers and you have also been given a target value. And what you have to do is you have to return this target value if it is found in the given array. And if it is not found in the given array, then what you have to do is you have to return the index where this target value will be inserted in the sorted array. Okay, so let us see some of the test cases. So let's say if I was given 1 3 5 and 6, if I was given the elements 1 3 5 and 6 and my target element was 5. So if my target element was 5 and this was the array, so you can, let's quickly index this array. So 0 1 2 3, so you can see that the element was present at this index, right, at the index number 2. So you will simply return 2. You will output 2 for this case. You will return the index 2 for this case. If the array was like this 1 3 5 and 6 again, but let's suppose that the target element now was 2. So if the target element was 2, then in that case what would you do? So in that case you will simply say that since it is not present, so let's quickly index this. So 0 1 2 and 3, so you'll be inserting this between 1 and 3, right? So after that, after doing that, what will happen? The output will be 1. Why? Because the index of the element which is 2 in this array, in this sorted array, the index will be 1. Why? Because this 1 is present at the first index. This 1 is the first element of the array. After that you will be inserting this 2 and its index will be 1, right, taking the 0 based indexing, right? This is what has been given in this test case answer as well. Let's quickly look at the next test case. So if you were given 1 3 5 and 6 and the target was 7, then what would happen? So if you, let's suppose that you were given 1 3 5 and 6, and in this case your target element was nothing but 7. So in this case you can see that 7 is not present, right? But where will you insert this? So you know that you will be inserting it towards the right. Okay, so how will you do this? So let's index this 0 1 2 and 3. So the index for the target element 7 will be 4. So in the output part you will be returning the index 4. This is the index where you will be inserting your number 7, right? So these are some of the cases. Now let's quickly see how we can do this. So for this, the intuition is very clear that since the array is sorted, so we'll be applying a binary search on this array, and after that what we have to do is we'll be checking the indexes, and let's look like how we'll be approaching this question using the binary search, right? So what we'll be doing is, since we have 1 3 5 and 6, so we will first of all initialize our low as 0 and your high as n minus 1, right? Once you do this, n minus 1 means the length of the array minus 1, because we are taking the 0 based indexings, right? So once we have done this, so we will simply first of all calculate the mid. Now let's look at the constraints. So if you look at the constraints quite quickly, so you will observe something, and the thing is that usually how we do it is usually people do this by while calculating the mid, they do this L plus high divided by 2, right? But this can be incorrect when the value of L and H, low and high, is large, and this is integer only, right? So in this case there can be sometimes L plus low plus high can be such that they exceed this value exceed the maximum value that an integer can hold. So in such situations you do L plus high minus length by 2. Why? Because L, that is low, plus high minus low divided by 2. If you will solve this expression, so you will only get low plus high divided by 2. This is the same expression, but in this way you will be able to encounter the overflow condition, right? So but this does not matter much. This does not affect our mid calculation, because the mid will come out the same like it came earlier, right? After this, what you will be doing, right? So you will first of all calculate mid. So what will be your mid? So since your low is nothing but 0 currently and your high is pointing to 3, so the mid will be 3 by 2, and that will come out to be 1, right? So now my mid is at 1, so I'll be at this element, right? I'll be at 3, and once I am at 3, so what I'll be doing, since I am at 3, so I will check that is this element equal to my 5. So it is not equal to my target element, right? So what will I do? I will check that whether the array of mid, let's say ARR of mid, if this element is greater or lesser. So since it is lesser than the target element, so what will I do? In this case, I will say that I need to change my search space, and what will I do is I will increase my lower bound, because since the current mid element is lesser than my target element, so in this way I need to I need to change my search space from mid plus 1 to high. That is why what I will be doing is I will be making my low as mid plus 1 in this case. Okay, what happens after this? So since I have done this, so my low now changes, and now since my low is changed, so what is the new value of low? So now my low will be pointing to 2. After this, what will happen? After this, I'll be calculating my mid again. So what happens when I calculate my mid? So once I'm calculating my mid, so my mid will come out to be nothing but 2, right? So now I will check that whether my array of mid is equal to the target element. So I can see that array of 2 is equal to nothing but 5, and my target element is also 5. So I'll simply return the index, right? I will simply return my low, right? This is what I can do. Okay, I will simply return my mid, because in this case you can easily observe that my mid is the current index at which my element is present, right? After this, there can be some situations. Let's say there can be 3 more situations, right? So let's quickly discuss about these 3 situations. Let's take another array, and let's try and see what can be the situations, right? So let's say if I have 2, 4, 6 and 8 as the array, and I have my target element as 10. Okay, so what is my low? My low is nothing but 0. What is my high? My high is currently 3, because it is n minus 1, right? And let's quickly index these elements: 0, 1, 2 and 3, right? So what will happen? I'll calculate my mid. So I'll get my mid. What will I get in the mid? So 3 by 2, that gives me 1. So currently I have 4 as my mid, right? A of mid is equal to currently 4, and what is the target element? The target element is 10, right? So you can see that array of mid is lesser than 10. That is why what you will do, you will make your low to mid plus 1, and you will be searching from mid plus 1 to high, because you know that your mid, the lower half, that is from low to mid up till there, the elements are lesser than the target value, right? So that is why you will want to search from the right side of the mid, right? That is mid plus 1 to high. After this, what we can do is, once we have updated our low, so what will my low be looking like? So my low will be now nothing but 2, right? So now what is my mid? So my mid will come out to be 2 again. So I can see that 6 is also lesser. At the index 2, I have the element 6. So since I can see that 6 is also lesser than 2, so 6 is also lesser than 10, right? 6 is also lesser than 10. So since 6 is also lesser than 10, so what will I do in this case? So I will update my low to mid plus 1, right? And once I do that, so what will I get? I will get low to 3, right? Once I get my low to 3, so in this case, now I'll check. I will check my mid. So my mid will be nothing but now 3, because mid is what? Low plus high minus low divided by 2. So this will come out to be 3. So now this is my element, right? So I will check, is 8 equal to 10? No, that is not the case. So what is 8? 8 is lesser than 10. So in this case also, I will update my low to nothing but mid plus 1, because I will shift towards the right. I will change my search space from mid plus 1 to high. Only then I'll be able to check, right? But what is my low now? Now my low will be nothing but 4, since my low is pointing towards 4 and my high is 3. So you can see that low has crossed mid, right? And we write that in the while loop, we write that low is lesser equal to high, but you can see here that my low has crossed high, right? So in this case, let's observe that if this was the array, then where would have we inserted this 10? So we would have inserted this element 10 at the 4th index only, right? Taking the 0 indexing, we would have inserted at the index 4 with the value 4, right? And if you return for this function, if you just return for this test case, if you just return your low, then that will give you the position where you will be where your target element will get stored, right? So you can see that if the element is present on the right side, is present at the extreme right of the given array, that is it is a new element that gets inserted at the rightmost point. So you can see that your low can easily handle that case, right? Let's look for a case where let's say that instead of this target value, now we have another target value. Okay, and let's try and see for that case also. Let's say my target now is 1. Okay, so what will happen in this case? If let's say my target value that I want is 1, so I'll initialize my low will be 0, and my high for this case will be nothing but 3. So now what will I do? My mid comes out to be what? My mids comes out to be 1. So I'll check that what is at 1. So a of 1 is nothing but 4 currently. Is 4 greater than 1? Yes, 4 is greater than 1. So in that case, I need to change my search space, and I need to move my search space from low to mid minus 1. Okay, mid minus 1, because from mid, if the mid element is greater than the target value, so that simply indicates that I need to check from between low to mid minus 1, because all the elements from, if the mid is greater than the if the mid element is greater than the target element, so that means that all the elements from mid to high will be greater than the target element, right? So that is why we need to check from low to mid minus 1. So in this case, I will update my high to nothing but mid minus 1. So what does my high value go to? So my high will be nothing but now 0. Why? Because earlier my mid was 1, right? So now my high will be what? High will come out to be 0. Since now it is 0, so what will I do? I'll calculate my mid again. So now my mid comes out to be 0. So since my mid comes out to be 0, so mid index is now 0. And what is the element which is present at the 0th index? So you can see that the element which is present at the 0th index is nothing but 2, right? So since the element at the 0th index is also 2, so what will I do in this case? So in this case, you can see that 2 is greater than 1, right? So what we do when the array of mid is greater than the target element? So in this case, I will move my low to mid. Since the target element is lesser than the current mid value, so that means that all the values from mid to high will be greater than my target element, right? So I need to check in the left part. So how will I do? So now what will I do is my search space will now change again. Why will it change? Because it will change simply because of the reason that I can observe that array of mid that I am having, it is greater than my target element, right? And when this is the case, so in those cases we usually update our high, right? So my high will now point to -1, right? And when my high points to -1, then in that case what happens? In that case, our condition is violated. What is the condition that gets violated? The condition that gets violated is while low is less equal to high. So since this condition is getting violated, right, since low is less equal to high, condition is getting violated, so my loop will now terminate. And after this, where will I insert my 1? So if this was the array, so I'll be inserting my 1 at the first position, at the beginning of this sorted array, right? And what will be the index for this? The index will be 0. And notice one thing, where is my currently low indicating at? So my low is also pointing to 0. So in this case also, you can simply return low, and your low will also be pointing to the index to the index where you will want to insert your target element, right? Now there is another case that we need to discuss, and that case is when my element that I want to insert, if it is lying between anywhere between these elements, right? So let's say if I want to insert 5, so if my target element that I want to insert is 5, so in this case you can see that I should be inserting it here, right? But let's start from the beginning. Low will be pointing to 0, right? My low points to 0, and my high points to what? High points to 3. What will be the value of the mid? So mid will be nothing but 1, right? So what is the element at the mid? So you can see that 4 is the element which is at mid, and 4 is what? Lesser than 5. So what will I do? In this case, I know that since my mid is array of mid, the element at the middle index, if it is lesser than the target value, so I know that all the values between the indexes low to mid, they will be lesser than my my target value, right? So in this case, what will I do? I will simply change my search space from mid plus 1 to high, right? So how will I change it? So I'll update my low to nothing but mid plus 1, right? So what will be my new value of low? So my new value of low is nothing but 2, right? After this, what will I do? After this, again I'll be calculating my mid. So what does my mid comes out to be? So my mid comes out to be 2 in this case, right? So now I'm getting my mid as 2, and what is the element which is present at 2? So 6 is the element which is present at 2. can I say that 6 is greater than 5? Yes, 6 is greater than 5, right? So the my array of mid, you can see, is greater than the target value, right? So in this case, what we do, we change our search space. How do we change our search space? So in such cases, we change our search space according to the mid value, right? So now, since the value that I am searching for, that is the target value, 5 is lesser than 6, right? So this is the mid value, right? So 6 is greater than 5, so that is why I will need to update my search space, and I need to move towards the left, because the current mid element is greater than my target element that I want to search for. So what will happen, I will update my high to nothing but mid minus 1, right? So once I update my high to mid minus 1, so the current value of high is current value of mid is what? Current value of mid is 2. So what will be my new value of high? High will be equal to 1, right? And in this way, you can see that now my condition of binary search, basic condition, is violated, that while low is lesser equal to high. So since this condition gets violated, so what is my low currently pointing to? My low is currently pointing to 2. And notice one thing, if I want to insert this 5 here, let's suppose that I wanted to insert 5 at this index, so what would have happened? If I wanted to insert my 5 at this index, then the index of the 5 would in the new array would have been this 2 only, right? So I can simply return low, and in this way I'll be able to get the position of my element, right? My target element, which I want to insert in the new array, right? So this was the explanation for this problem. Basically, we tried to cover a few cases. If you there can be 4 cases, right? First case can be that you get the target element, right? So if you get the target element, so if the target element is equal to array of mid, then you can simply return array of mid, right? Otherwise, there can be sunken situation such that the target element is wants to target elements is at the has to be added to the last, right? It has to be added after the whole array, that the initial array is given, and you want to add the target element one after that, right, in the end. So in this way, you can also return, you as we saw that you can return low for this also. And for the third case, there can be a situation such that you want to add your new element or target element at the beginning of the array. So in this case also, we saw that we can return low directly, right? And there will be the fourth situation, and the fourth situation is such that basically in the fourth situation, what you have to do is, in the fourth situation, your element has to be inserted anywhere between the array indexes, right? Anywhere between, in between. So in this case also, you can simply return low, and your low will be pointing to the index where you should be putting your target value, right? In the sorted array, you will be inserting your target element at the low index in the sorted array, right? So let's quickly read the code for this. Like, the code part is very simple, like the explanation only. So if you will see this code, so I'll initialize my low to 0, and I'll initialize my high to n minus 1, because I'm taking 0 based indexing. Then after that, I will check that my low is lesser equal to high. This is the condition for the binary search. After that, I'll calculate my binary search using this technique. This is to check that there is no overflow, right? After that, I'll check that if my nums of mid, if it is equal to target, then I will simply return my mid, because that is the index at which my target element is present. If that is not the case, if my current mid element is lesser than my target element, so that simply means that I need to change my search space from mid plus 1 to high, because if the mid element is lesser than the target value, then all the elements towards the left of the mid will also be lesser, right? So that is why I need to change my search space from mid plus 1 to high. And so that is why I'll update my low. And in the else part, if the middle element of the sorted array, if it is greater than my target element, so that simply means that all the elements towards the right of the mid will also be greater than my target element. So that is where I'll not be able to find my target element, right? So that is why I'll change my search space from low to mid minus 1. So that is why I'll update my high to mid minus 1. And in the end, if this while loop terminates, so after that I'll simply return low, which will be pointing towards the index at which I should be inserting my target element, right? So for this, since we are using a binary search approach, so the space complexity will be order of 1, because we have not used any extra space, and the time complexity for this code will be nothing but order of log n, because binary search takes order of log n time. So this was the code for this problem, and make sure to subscribe the channel and like the video as well, because we bring video editorials related to codeforces, atcoder, and Leetcode editorials as well. So thank you everyone for watching, and have a great day.